Welcome to this presentation. We're going to be looking at applying bearing loads. This is the reason for this is in ANSYS and SolidWorks. Sometimes the applying different loads is really easy. Sometimes it's not quite intuitive how they have it set up. So we're going to do it for the same setup, but we're going to do it both in ANSYS and SolidWorks so you can see the differences here. And if this sheet is in the notes section, if you can find the link down below in the notes. So go download that and you can follow along with the setup and get some understanding of how to apply, in this case, bearing loads in ANSYS and in SolidWorks. Before I get into this, I want to show a video first. This is from SolidWorks, and it's on testing handcuffs. And go over here to it. And the point of this I want you to think about here, and the highlight of the video is how do we simulate something that we're looking at how it works. So in this case, it's handcuffs. How do we simulate how the handcuffs could pull apart? And if we're doing that in simulation rather than an experiment, how can we think about that? And so let's watch it and we'll talk about it briefly after we finish.
As a good engineer, you understand the benefits of simulation. The ability to carry out virtual tests on your product to gain knowledge of its performance in the real world before you make it is invaluable information during the design process. So why don't we all do it? Perhaps it's a lack of confidence, or you just don't feel that you have the knowledge to set up the simulations correctly. But guess what? With SolidWorks Simulation, if you know how to set up a physical test, you know enough to set up a simulation. Take these handcuffs, for example. If asked to test the ultimate strength of a pair of handcuffs, you would probably simply put them in a tension testing machine and pull. But what if you didn't have the handcuffs, and all you have is the SolidWorks model? What now? What loads and restraints do you use? And what faces do you pick? For a novice user, there are just so many choices, it can be overwhelming. Rather than diving straight into the problem, let's use our knowledge of the physical test to guide the simulation. Just as in the physical test, let's include the grips of the testing machine. The beauty of working like this is that the loads and fixtures become very simple, and SolidWorks takes care of the rest. Once we have completed all the loads and restraints, we can hide the grips. A big advantage of using simulation is that you can slow everything down and see exactly what is happening. As the load increases, you can see the stress buildup in the fixed frame of the handcuffs. We can see the frame starting to bend until the teeth on the moving frame are pulled out of the ratchet mechanism and the handcuff is released. Although the frame still has some residual strength, our prisoner would be long gone. So how good was our simulation? Well, we took a pair of handcuffs down to the materials lab and put them in a tension testing machine. Just as in the virtual test, the handcuffs look good until, with the gentlest of pops, the teeth pull out at a load of 5 kilonewtons. If we continue to increase the load, the handcuff frame takes all of the load until the ultimate failure load. Comparing the physical test and simulation, we find excellent agreement for both the failure load and how the handcuffs fail. So with SolidWorks Simulation, you can judge the impact of any design change you make on the overall performance of your product, ensuring that you achieve the best design possible. Although the simulation of your products might seem daunting at first, by using SolidWorks Simulation and creating your virtual test the same way you would do a physical test, you too can see how your products will perform in the real world without having to build expensive and time-consuming prototypes. With the physical test, all you have at the end of the day are the broken parts and a results graph for one test case. But with the virtual test, you can look at every possible result and loading scenario, time and time again, giving you a greater understanding of your product's performance so you can make good engineering and design decisions, making your products better and your customers more satisfied. To find out more, contact your local SolidWorks reseller to see how easily you can...
Not necessarily making this a big ad for SolidWorks, but I did like the focus they had on their video. So, big thing I want you to think about as you move forward with simulation is that we can do a lot of the stuff we're testing or when we're developing a part, thinking about how will we actually test it in the physical case, and we can try to set up the same case in the simulation. One big piece there is figuring out how to apply the load actually on the handcuffs is a little difficult, and I've seen this before, especially when applying loads to the top of bolt heads. In their case, they drew the grips, and then they put the loadings on the grips and let the grips apply the load to the handcuffs like what happened in the tensile test machine. And so with a bolt head, you would create a wrench, or at least part of a wrench, and you'd apply the load to the wrench, and the wrench would apply the appropriate loading to the bolt head. So try to think of it from that perspective. It may actually make it easier as you apply loads in simulations that you may run in the future. All right, so let's get into this. We got the bearing loads, and we're going to do this in ANSYS. So we're going to set up we got concrete floor and we got a wheel. In ANSYS, we're going to have concrete and structural steel for the two materials. And so let's go ahead and do that. So let's get in SolidWorks to bring those things up. So again, this is in the SolidWorks folder. Should be able to download applying bearing loads and unzip the folder, and you'll have these. Actually, I'll probably take this out because I already saved this from last time. But we want is the concrete floor and the wheel. And we actually want this in an assembly. So let me cancel out this. I'm going to do a new assembly to bring these things together. Go ahead and browse. We'll get let's bring the concrete floor first. And I'm going to green check the concrete floor here. And then we'll come back here to assembly, insert component, and also insert the wheel. And I'll just put it on top there for now. Now we need to mate this wheel, make sure it's connected to the concrete floor here. So let's come in here and click on mate. So let's get this edge right here. Make sure these edges are exactly lined up. So we'll go this edge and this edge. All right, so those look good. So now we can move it on that edge, but you see how it rotates there. So let's now mate this face with this face. All right, so again, now it won't turn, but it can still shift back and forth there. That's okay. We'll fix that when we actually apply the constraints when we do the simulation. So I'm going to go ahead and check that and leave it there. All right, so let's zoom out here. So that's the setup we want. We're going to do an ANSYS first, then we'll come back and do it in SolidWorks. All right, so we need to save first before we take it into ANSYS. So we'll save it. Yep, let's rebuild that. And we'll save it as wheel and floor assembly. All right, so now I can take ANSYS. And actually, I was looking at SolidWorks 2015. I'm using 2013. So ANSYS shows up here in my version, obviously. I believe in 2015 it shows up under Tools. And under Tools, I get the menu to show up here. A couple menus down here, ANSYS, this basically the same thing will show up under Tools. So if you have that, that may be where it's showing up at. So I'll go ahead and take this into Workbench. Again, if you have need to save it as a step file, you can save it as a step file and bring it up into Workbench as a step file.